Okay, so this is an introduction on smart contracts and how to write smart contracts for the EOS.io software for the EOS blockchain. I want to start off saying I'm using Ubuntu 17.10 as my operating system. I'm on the dawn-2.x release from GitHub, and I've heard Dawn 3.0 is supposed to be, or hopefully will be, released end of March, beginning of April. So some of the function names may change, some of the syntax may change. However, I believe the concepts will stay relatively the same, if not exactly the same. So what I really want to get across here is the concepts on how to write a smart contract, how to interact with smart contracts, the structure and framework of smart contracts, and just the basics. So if any of the syntax changes or if I'm incorrect about anything, please feel free to leave a comment down below. All right, let's get into it. So what is a smart contract? Now, I think because smart contracts are such a new term, such a new terminology, and just a new technology that there's really not a solid definition for it. So I think one definition I found online is a smart contract is a computer program that directly controls the transfer of digital assets between parties under certain conditions. So it's not like a super solid definition. It's really vague. It's you know, it's pretty vague. It leaves a lot of interpretation up to the reader, the developer, which is, I think it's a good thing because it lets you get creative and lets you do things your own way, because it's basically saying the transfer of digital assets between parties. But what is a digital asset? I mean, I guess it could be like Bitcoin, a cryptocurrency. It could be more of a traditional asset that's been digitalized, like a security or derivative. But then, I mean, I guess it could even be like a like on a decentralized application or a comment on a decentralized application, because it's really just showing that you have ownership over that like, or you have ownership over that comment. It belongs to you. It's your asset. So to me, I guess a smart contract is a computer program that's data, and its database lives on the blockchain, so therefore it's executed in a decentralized fashion. All its data is stored in a decentralized fashion, and in EOS we're talking about having it on the EOS blockchain, of course. So what is a smart contract in EOS, and how smart contracts in EOS work? So on EOS, if you remember, you have accounts, and whenever you make a smart contract, it needs to have an account. A smart contract can only have one single account with it, and they usually have the same name. So you make a smart contract, say contract 1, you make an account called contract 1, and then you'd set that smart contract to that account. And you're probably saying, okay, so does that mean that only one person owns that smart contract, right? But that is not necessarily true, because if you remember, in EOS we have these accounts can be owned by multiple people, and you have that permission hierarchy to them. So you can have an account with 50 people on it, all with different permissions, and then set a smart contract to that account, and those people can then interact with that smart contract according to their permissions, as well as other people that are not on that account can also interact with it. It's just when you want to make some sort of change, or if you require a certain permission on that smart contract, you can set that up in your account. And here we go. Here's an example here. You have an account with multiple people, and let's say if you wanted to say that you have the owner permission, you need to meet a threshold of 2. So you have Bob here with a weight of 1 and Stacy with a weight of 1. So if they need to say, if they need to sign something as the owner, they need that threshold to meet the threshold of 2. So both of them need to sign. So therefore they're both technically the owners of this account, and if you put a smart contract on this account, then they would be the owners of that smart contract. So examples, because it's kind of abstract just looking at it like that. I thought of one where you had like a renting smart contract where you would rent something out, and typically you'd have a land, or let's say you're renting out like a home or something. You'd have a landlord and a tenant. So you could do it one way, where the landlord is the owner of the account, and then they put a smart contract to that account. So the landlord basically owns a smart contract, and then the tenant comes in and would sign on later. So if that was the case, you know, the landlord would basically have the control of the smart contract, and then, you know, a tenant would just be able to say, like, pay their rent, or submit requests, and submit forms and sign other things. But really the landlord would be the owner of the contract. Now you could do it another way, kind of like this, where you could have the landlord and the tenant be the owner, and therefore they would both have to sign off on some actions. So say you wanted to change the price of rent. Well, you can't do that to this contract unless both the parties sign. So, you know, you can mix it up, change it around, and hey, if you have more people involved, you know, you can change your structure around. So let's see the tools that we have to do this. We have a couple tools here. I mean, we obviously have the EOS daemon, the block production going on in the background, and clear. Yeah. So I'm inside EOS here, and we have a couple that's going to build. Now in here we have a couple programs. We obviously have the EOSC program inside the client, inside programs, but we also have this directory tools here, where if you go into tools and you do an ls, we have this one called EOS CPP. So now this CPP tool right here, we can use to compile smart contracts into WebAssembly, and then we can use EOSC to set those compiled smart contracts to accounts. So let me go back here. So when you write a smart contract, I'm putting all of mine inside this contract directory. So I go in here, now the first thing you're going to do when you create your smart contract is you name it, and then you create a skeleton for it using the EOS CPP tool. So I mean, you can always set up well, what you can do is you can set up environment variables and stuff, so you don't have to type the full path, but I am typing the full path. Tools EOS CPP, and when you start a new one here, you do a -n for name, and then you give the smart contract a name. I'm going to call this YouTube demo, and it will say created a YouTube demo from skeleton, and you do an ls, you get a new directory called YouTube demo. You cd to YouTube demo, do an ls, and we get an ABI, a CPP, and HPP. This is the application binary interface. This is your C++ source code and your C++ header file. Now I called this one YouTube demo, so I should have an account called YouTube demo. So if I do go back to programs, EOSC, get account YouTube spell it right, YouTube demo, bam, I have an account called YouTube demo. So eventually, now you can always make this account at a later date and have wallet for the keys and everything, but eventually I'm going to set my YouTube demo smart contract to this YouTube demo account. So I already made this account and a wallet for the keys. If you don't know how to do that, you can go back to my previous video It shows you how to create accounts and store the keys in wallets. All right, so now let's take a look at this. Sublime dot. So now, as of right now, it will, when you do that -n and it creates the smart contract, it will kind of give you a like a boilerplate for everything. So if you come in here, you can see, okay, you just get the EOS lib and stuff in your header file, nothing really here. And then you get like a main inside the demo.cpp, and then you get a whole bunch of stuff in your ABI, which I will explain in a moment. So here, let's see, let me make a new one here for explanation purposes. So basically how this works is you're gonna have a user, you know, running a client, and they're gonna send a command, and the command they send is gonna be called an action. They're gonna send an action, and that action will then go to your smart contract, which will be processed, and that action itself has a data type associated with it. So it's gonna have a data type, and this describes the data that is with the action. And this is in C++, we're going to use structures. So this will be you'll see in a second, this will be a struct that you have to define as your data type. So a user is going to send this action. Here, let's move this. A user will send this action to the smart contract, which will then handle it, and if the data needs to be stored to the blockchain, it will be stored in a table on the blockchain. So data that gets stored is in a table, and this is a key value pair. And this again also has a data type, which is a structure that you can write in your smart contract. So all your structures and stuff kind of go inside your HPP. All your handler code, so how you handle these actions, go inside your CPP, and your ABI is a JSON representation of your smart contract, which basically makes it easy for you to interact with it. So you'd put like an action, and then that would have a data type. So here's like kind of a boilerplate and that it gives you right away, and we can dive into this a little bit more later. But basically you have actions array, you have a tables array, and then you have a structures array, and then this is just kind of like a type def up here. But your actions array, your user will send an action. I'm gonna say like make an action, like a transfer action, and that transfer will have a data type of transfer, and that data type transfer is described up here. And inside the transfer, the data that it's gonna look like, you're gonna have a from account name and a to account name and an amount. So this is just kind of like the example it gives you at first, but we're going to obviously change that one around. So let's close this. So let's talk about the C++ file here. So it starts off, and we're using EOS.io. So it starts off with two functions, a init and apply. Let's see, init and apply methods must have calling Z conventions. I'm just going to delete this. Get rid of this comment. Get rid of this. So init and apply. So init is basically like your initialization code for the smart contract. So it sets up your environment before your smart contract runs. So if you need to have anything set up before anything else happens, you're going to throw it in the init. So the init only runs when the smart contract gets published the first time. So in this case it says init world. We're just going to call this one, we'll just send this one to YouTube demo. So this only happens at the very first time your smart contract gets published to the blockchain. Then the second thing down here is your apply. So as I said, you're sending a user sending actions in. So this is kind of like your action handler. Your apply is going to handle all the actions that you send to it. And you pass in code, and then you're going to pass, and well, the arguments for this is the code, which is the name of the smart contract that you're running, and then your action, which is the action that you're going to specify. And again, your action can be can be anything, and you're going to describe this one. Also, you put this one in the ABI file here. So for example, this one would be transfer. Now, the first common thing you're going to do here is you don't want this to run any code, so you want to make sure that the code that you're running here is in our case, YouTube demo, and then we can put this in here. And then in our case, we do well, I guess what we'll do eventually is we'll add in here if action this, do this action, apply this handler, and then you're going to write the handlers up above here. So if in our case, if we get, as long as it's called YouTube demo, it doesn't matter what, we're not checking for any action, but we'll go in here and we'll print, we'll just print out you sent any action. And the cool thing about this is I think that's all you need, because right now we're not even using an action. I'm just going to leave this in here because we can change this later, but it doesn't matter for right now because we're not even just defining an action. So what we got here is we have the ABI, the CPP, the HPP. So we're going to make one called a WAST, a WebAssembly text file. So we're going to compile the CPP down to WebAssembly. So to do this, we got to go back to Tools, EOS CPP-O, and then you give it YouTube demo dot what you want it to be, WebAssembly, what you want to compile to, WebAssembly text, and then YouTube demo dot CPP, and you go ahead, hit enter. If everything is good, it will go ahead and compile it for you. You can do an ls and you'll see the WebAssembly right here. If it doesn't compile for you, it will throw a bunch of errors here, but it's actually pretty good about telling you what the errors are, and I will point those out to you. So now that we have the WebAssembly text, we need to use our program EOSC to set the contract to the account. This is the account here, so the account is YouTube demo, and then we got to give it the YouTube demo dot web assembly, and then here's where the ABI comes in, YouTube demo dot ABI. So basically, when you set this contract, you're going to set the WebAssembly and the ABI so you know how to interface with it. And if you hit enter and everything goes well and good, you see that it goes through. And let me go over to this block producer, and you can see right here we get our init function, which was, I guess I could have left the init in there, but you see YouTube demo getting printed out on the daemon. So if you remember, if you looked at this right here, we had YouTube demo, and it got print, if you noticed, yeah, so if you noticed, it got printed out 3 times there, YouTube demo, YouTube demo, YouTube demo. So if you're wondering why did it get printed out 3 times, you can go over to the GitHub docs, and in their example they're using init world, but it basically says this is executed 3 times. This is not a mistake. When the blockchain is processing transactions, the following happens. The first printout is one, EOSD receives a new transaction, creates a temporary session, attempts to apply the transaction, succeeds, and prints your initiation function. Second one, EOSD starts to produce a block, undoes all pending states, pushes all transactions as it builds a block, prints your initialization code a second time. And then finally, 3, EOSD pushes the generated block as it received from the network, and it prints it a 3rd time. So there you go. That's why it prints 3 times if you're wondering, but it's not important. So now we got it going, and now we can interact with it. Hoo-hoo. So what you do here is you can push a message to your smart contract, which is YouTube demo, and then you can push. Now here's your action. This is going to be your action here. Now we didn't even define an action yet, so there's I don't think it will work, right? You can just say like my action, and then you'd put in data here. So in here you just put in, well, what we can do is we can just send it A, B, C, D, and then you have to, this is another thing in Dawn 2, you have to put the scope of what you're using, but I think they get rid of this in Dawn 3. And the last thing is you could do permissions, but we don't even require permissions right now. So So we can make a transaction. So I just made a my transaction to my code. And if you look here, you sent any action. And it's 3 times again. So basically I just sent, let's go through this one more time. So basically I pushed a message, and this is where the syntax might change going forward. But basically, I'm pushing a message to the YouTube demo account, which has the YouTube demo smart contract on it. I pushed my action to it, and then I gave it arbitrary data, because the data doesn't matter. We're not handling anything right now. And then I put in my scope, but you probably won't need that when you get to Dawn 3. So when I sent that, my smart contract then received I knew that I was on YouTube demo, and it just printed out you sent any action, because I sent any action to it. So there you go. That's the very first, I mean, that's basically a functioning smart contract, although it does absolutely nothing. It's a functioning smart contract. So the next thing we can do here is we can actually have it do something legitimate. So we can, let's go ahead, let's make an action here. So we'll say if action equals hello, then what we'll do here, this will get interesting. We will send to the, well, here, let's explain this. So now if we send the hello action, we're gonna go to some specific handler, and we'll just call it apply hello for right now and get back to it. So now when I'm writing the apply hello, it's gonna come up here, and we're gonna write some sort of apply hello. But now the first thing is, remember what I said, all these actions have a data type associated with them, and you got to explain what type of data you want. So I kind of like starting with the ABI. You can start anywhere. You can start with this HPP, but I kind of like this. So we're going to make a hello action. It's going to be of data type hello. Keep it easy. Let's hijack this one. So this one will now be called hello. And then what type of data, or what are we describing inside here? Well, let's just call this one. We're going to do hello, and all we need is a person. So let's just call this person, because we're going to say hello, a person's name. We'll just call it person. And that's all we need. And now how this works is this is going to be the variable name, and then this is going to be the data type of that variable. So right now I'm going to say a person is going to be the variable, and then that person is going to be stored in a data account name. And then up here, this is kind of like a type def, which is saying a new type name is account name, which is really going to be, it's just an alias for a name. And then name is actually just an alias for, I think it's a uint64. So now we need to actually write code for this structure here, because this is just defining it. So now we have to make a hello structure with a person inside of it, with a person data field of data type account name, and then we need to make an action called hello of that same data type. So to do that, we come into here, and now here's where we're going to go. We're going to say, all right, we want to define a namespace. So we're going to namespace, and then we'll call this YouTube demo namespace, and then we'll create a structure in here, right? Because this is the type name hello, and inside here this will be an account name data type with a variable called person, and then suppress that. And account name, I believe we should be okay, but I usually like adding in using namespace EOS IO, just in case you need some EOS IO namespace functions. So now, yeah, here we go. So here, let's just space this out a little bit. So now we have a structure called hello, which is going to be the data type of the hello action, and it's got a person with an account with a data type of account name. So now in here we can say, all right, we want to use the YouTube demo namespace, and here we want to go ahead and do the create a YouTube demo namespace in here, which takes, oops, wrong place. And then we'll return void, and then we'll call apply hello up here. And then this will take constant per hello structure, call it H, reference to hello structure H. And here we can go EOS IO print, it says hello comma EOS IO name H dot person exclamation mark. So now when this apply hello function runs, we're going to pass it a variable called H, which is of data type hello, which is defined here, and then it's going to print out hello your data type H person their name, which is defined in here as account name, and an exclamation mark, and that's it. That's all this is going to do. So down here, if we want to use it down here, we can go ahead. So now down here we'll use the YouTube demo namespace, use the apply hello function. Now we have to grab the current message that the user is sending, cast that one to type again of YouTube demo, or use the type hello, use that type, grab that function, then send that one off. So now basically what happens is you come in here, you get, I'll space this out a little bit. You get the YouTube, make sure you're using the same YouTube demo contract, you get the action hello, then you go inside, we'll apply the hello method from the YouTube demo namespace here. We'll grab the current message of type hello, make sure it's that structure, we pass that in up here, we get the print hello, and then we'll get that person's name that we sent along with it. And we have that defined here, and again we have in here, let's just make sure everything, we have the hello of type hello, we have the structure defined up here of account name, person name. So good, you're all set. So now you've got to compile this again, so you go back to tools, EOS CPP, and do the same thing, -o YouTube demo-WebAssembly text from YouTube demo.cpp, build it, no errors. Hey, that's pretty good. And then now we want to go to programs, EOS, set contract to the YouTube demo, and we'll use the YouTube demo WebAssembly and the ABI, set it, and we're off to the races. Again, we get that YouTube demo, that init function, because we published it. Now in here we can push our action to it, so we can say push message to YouTube demo account. And now which action? Now we've called it hello this time. And now here's where that ABI comes in. It comes in handy. That JavaScript notation. Actually, I guess you can't really see it both. But yeah, so now we have an action which is going to be of type hello, which we just typed in here, right? And now we got to give it the data for the hello action. So now we got to say, all right, we're going to use this data up here. We're going to have to give it a person, and we're going to give it an account name. And whenever we do that, that's what's gonna pass through. It's gonna do that, the key value pairs, right? So what we do here is we go in, well, we're gonna say, all right, we're gonna give you a person, and we're gonna give this guy a name, and like every great programming tutorial, we're gonna call him Bob, and then scope YouTube demo. And we're off to the races here. We can see we sent a type hello to person Bob. We go over here, we get hello Bob. So 3 times again. So basically our handler function caught the hello action, and then it passed in our structure that we gave it with the JSON over here. It passed in the person Bob. It passed that in up here to our apply hello function, and it went ahead and printed that out to the screen. So that's basically, I mean, that's your basics of smart contracts. That'll get you started. The next thing to talk about, I guess, would be to use tables, because right now we're just printing this out to the terminal screen, right? We're just using the EOS print with the data. The next thing we'd do is we would now store that, or we'd create a table, and then we'd store this information onto the table, and then that way it'd be stored to the blockchain. But this is just basically how you interact with it, and how you can go ahead and get started writing the logic to a smart contract. All right, there you have it.